All right, it's that time. Prealgebra. I've finished the second chapter. What was this all about? What did I learn? It's all about exponents. So it was great to just further solidify my ability to understand and work with exponents. I took Gen Physics 1 last semester, and we actually went over exponent rules the first day, which is crazy because it's a pre-algebra. It's like, but yeah, I mean, no matter where you go, you need to know how to work with exponents and exponent laws and properties, no matter, STEM classes I'm talking about. So yeah, exponents. Okay, so squares, this is to the power of 2. It comes from the term, comes from a square, because it's base times base, right? So that's where the term square comes from. So an exponent is really just repeated on multiplication, and multiplication is repeated addition. Interesting how that works. So 2 squared, 2 to the third, let's say, that's 2 times 2 times 2. 2 times 2, that's not a good one. I think multiplication is repeated addition. It is. 3, let's just say 3 squared. 3 times 3, 3 squared. 3 times 3, so that's 3, 3 times. So 3 plus 3 plus 3. There you go. That's how you can translate addition into exponents, exponentiation. So the term power is actually a term referring to the base and the exponent. So that's interesting. The base and the exponent and the power, those are terms I've kind of learned this time, or this path through. I had heard the terms, but I never knew that power refers to the whole term, including the base and exponent. Cube then is to the power of 3. So yeah, you say 2 to the power of 4. So 2 to the 4th power is a power of 2. Just some terminology there. So then it went into higher exponents, negative exponents, 0 as an exponent. Anything to the power of 0 is 1. Even 0 to the power 1. That's something I learned. That's interesting, right? So negative exponent is basically like, how would you say that? It's basically the negative term in the exponent is like the reciprocal of the base. So if you have anything negative 1, that's the reciprocal of that number. And so that's how you can think of it. You can say the negative part, you can split it up due to the, commutative property of addition, potentially. You pull the negative out. And so if it's to the power of 8, or to an exponentiation to the power of 8, or negative 8, you can pull the negative out. Negative 1 times 8, and so really it's like it's the reciprocal of the base times, or it's the 8th power. So some exponent rules here. How do they work? How do they behave? So if you, let's say same base, so let's say 3, for example. 3 to the power 2 times 3 to the power 6. So 3 to the 3 squared to the times 3 to the power of 6. If you have same base and they're multiplied together, product of powers, same base, you can add the exponents together. So it would be 3 to the 8th. And that makes sense because if we expand out and say that 3 squared is 3 times 3, and 3 to the 6 is 3 times 3 times 3 times 3 times 3 times 3, and those are multiplied together, you can get 3 to the 8th. How about for quotients? The same base quotient is going to be similar, but you subtract. So 3 to the 6th power divided by 3 squared is 3 to the 4th. How about a power of a power? So 3 squared, and then in parentheses squared. Well, that's going to be multiplying the exponents together. So it would be 3 to the 4th. That makes sense again. If you just expand out by what it means to be a power, it means multiple multiplications. Okay. How about, I feel like there's other things. Product or power of a reciprocal. If you have 1 over x squared, that whole thing squared, it can be written as 1 over x squared. Right, so power of a product. So say 3 times, or let's say x times y, the product of x times y to the power of 4. That really is x to the 4th times y to the 4th, because again, expand out the exponents. What do exponents actually mean? And so power of a that was power of a product. So power of a quotient. Again, it's very similar to the reciprocal. If it's x divided by y, and that whole thing is to the squared, so the second power, then it's x squared over y squared. I think that's basically everything from this chapter on exponents. One other thing I just remembered. 0 to a negative exponent is undefined because you can't have a reciprocal of 0. You can't divide anything by 0. So, all right, let's see if I got everything on the main points. 8 properties of exponents. Product of power, same base. Quotient of power, same base. Product of product. Power of product, power of reciprocal, power of quotient. That's 6. We're missing 2. Power, base, and exponent, squares, cubes, 0 exponent, negative exponents. 0 to a negative exponent is undefined. Process of raising number to a power is exponentiation. Okay. Exponentiation. Perfect square. That's something I forgot. Perfect square. Perfect square is basically the result of, it's a number that is the result of the square of an integer. So we haven't talked about square roots yet, but the perfect square is basically if you take the square root of a number, it's an integer. So perfect cube will be the cube of a integer. Every square is non-negative. Oh yeah. This has to do with the whole thing of like, is the exponent, is the negation, is the number being squared negative, or is it being times by -1? So is it in parentheses or is it not in parentheses? If it's even in parentheses, it will be positive. If it's odd in parentheses, it will be negative. That was a decent part of it. Square of negation does not equal negation of square. Square of negation will be positive. Negation of square will be negative. Square of product equals product of squares. Because of commutative and associative properties of multiplication. This is what I already, square of product, or power of product is a more general term. We already discussed that. Oh, here's a little interesting way to go from one perfect square to another next. You take hold up, what do? You take the previous term times 2 plus 1. So say 4. Take the previous term, 4, we say we want to find the next perfect square. Take 4, add it to 2 times itself. No, that's not gonna work. How do you do this? Previous terms 2, 4 plus 2, 2 plus 1. That's not it. Oh yeah, it is. Yeah, because it's 4 and then it's 9. So you take the current perfect square. You want to find the next perfect square. You take the perfect square. You add it times 2 times the previous term, which would have been, what was the previous? What? All right, let's do 3. So start with 9. You've got 9. The next perfect square is going to be 16, right? Okay, so you got 9 plus 2 times 3 plus 1. 4 times 2 times 2 plus 1. Okay, so you take the previous term, and then you take the integer. If you took this previous term, square root it, times by 2, plus 1. So 16 square root is 4, so 16 plus 8 plus 1. Okay, 25 square root 10, or 5, so times 2, 10. That's 35, 36. That's how you do it. Previous base squared plus 2 times previous base plus 1. There you go. Got it. Boom. Power of negation, even versus odd. That's probably one of the 8 I missed. A to the n. What the? Oh, product of powers, same exponent versus product of powers, same base. So if you had, say, 3 squared times 2 squared, that's what we're talking about? Okay, then it would be 6 squared, right? Okay. So if it's the same base, then you can keep the exponent and then multiply the bases together and then have the product be the new base. Okay. Interesting. Product of powers, same exponent. That's one I totally didn't remember. And then quotient of powers, same exponent. Same thing. You'll just do the division. So if it's 8 squared divided by 4 squared, you'll keep the same exponent 2, and you'll actually just perform the division on the base. So it'll be 4 squared, 16. Does that make sense? 64 divided by 16 is 4. What did I say? 8 squared divided by 4 squared. That's 4. And then, okay, yeah. 8 divided by 4 is 2. 2 squared, 4, yep. Cool, we got that. So those are the 4. Product of power, same base. Product of power, same exponent. Quotient of power, same exponent. Quotient of power, same base. Power of power, power of reciprocal, power of negation. So there we go. All right, not bad. That's good to wrap it up for chapter 2 on exponents. Next chapter that I'm been working through is number theory. Number theory is the study of integers. So new term that I learned. I had heard of the term. I didn't know it meant the study of integers. So that's it for today. Talk to you soon. See ya.